Yeah, so on the basis of the distribution and on the basis of the package which would like to install it, you need to refer the Google. But why I'm talking this as Google is, yes, as we know that M and app to get, they're all like different utilities on the basis of the type of distribution. But package names, how do we remember it? We cannot remember it, right? So package names, that is on the basis of the distribution, we need to find it from the Google. Yes, HTTP is a package for RHEL to install HTTP server, and Apache 2 is a package name on the Ubuntu based systems. And finally, the how to verify this installed package. Yes, that's where understanding and then starting and stopping approaches is the systemctl start or restart or stop or status or enable. Enable is whenever you reboot the system. Yes, automatically we're expecting that HTTP service should be up and running. That's point of yes, we need to use it enable option as well as. And finally, what is the deployment directory of the HTTP server is? Yes, var HTML. This is for HTTPD. Like that Tomcat, that is a different directory. And Nginx, that would be different directory. Yes, on the base of the service which we are going to talk it, yes, the deployment path is going to change. Yes, one by one tool, whenever we are discussing that tool specific wise we'll talk it. But Apache, if you are working with that, what is the deployment directory is? That is so what is the deployment directory for the Apache HTTP services? Var www HTML. So var www HTML. So this is the deployment directory of this. So if I hosted any the HTML files or the PDF files, I can access that through IP address of this server and port number. I can access it remotely. Yeah, so that is about some points: starting, stopping, and deploying and installing the HTTP. And finally, how do we test that whether Apache is running it or not, or installed successfully or not? So we can use the different approaches. One is service level verification, that is systemctl status HTTPD. Second one is, as we are talking to the process management, process-wise verification, that is with the ps-ef command. And these services are going to use the ports. So port, what is the port of that HTTP service is 80. So if the port is listening, that means the service is up and running. But how do we check it that port is listening it or not? That is netstat command which we can use it, port-based verification. And on the system itself, we can check it with the curl command. Yes, that is a command line based URL, we can use it. The curl with that URL with the local host, we can check it that the locally the service is reachable or not. And externally also or remotely also we can check it that whether the service is reachable or not. That is by using that in the browser, the system, I mean on the system where it is running that the system IP address with port number, we can verify that. These are all very, very important, the verification. Whenever you see that 5xx status codes from that application, 5xx, then immediately you need to run these commands and check the status of the services. Yeah, remotely checking about it, the service is reachable or not. And yes, as a latest version, so by default firewalls are enabled and these are all blocking. But HTTP service, if you like to access that remotely, you need to allow that or accept for the HTTP service. Yes, is that the firewall command utility and enable that is available external. Which one? HTTP service. And restart the firewall process. Yeah, so this is about the yesterday, the important concepts, understanding the service. And tomorrow, whenever we talk to Nginx, and you should able to follow that with these steps, and you should able to manage the Nginx also. But these are all the generic concepts, but we have applied it to the Apache. Is it clear about these points? Any queries, questions, please let me know.
No, we are good. Thank you.
Yeah, good. Yeah, so these running nodes that has been given over here. Cool. Now let's move into that another concept or another kind of management activities as a DevOps engineer, which we should know from the Linux, that is networking commands also. The networking. Before talking about the networking commands, first of all, networking topology is very, very important. Yesterday, we are using some commands on the networking level, verifying that the IP address, verifying that the ports. But those concepts are not enough. So we should know that the network topology and how the networks are going to working this in the real time. Okay, so let's talk it this. What is a network and what is the CADR, what is the subnet mask, and what is we'll say that VPC, all these concepts later in the AWS. Yeah. So first let's understand some important terminologies of the network. Suppose before understanding the networking, let me just talk it this one example. Suppose I'm going to courier the one of the order to my friends, a friend address. But I need to enter the complete details of that address, right? Otherwise, it doesn't reach it. Yeah, so I mean, from my side, if you just talk it, I'm the source. I'm going to send some data. From the source, we are going to send some data to the destination. That is to my friend. But to reach from the source to the destination, that mailing address, the mailing address should be valid. If I give that invalid mailing address, then my packets, whatever I'm trying to transfer it or sending it, my friend doesn't receive it. This is generic concept. I mean, that is, yeah, mailing address is very, very important. But mailing address, how that would be? So in which country he is in that? In that country, like in which state? In the state, like the district, and district to the mandal to that. If he is in that village, and in that village, yes, house number. So all that details required, right? That is, so from the source to destination, if we're transferring that any data, so that is going to use the source required to use it, some destination, the unique location, a unique IP, we say that's in the networking IP address, but we say that here house number. The same concept. Suppose if I'm using this internet and if I'm uploading the file or if I'm downloading the file is nothing but somewhere this file is available and I'm trying to downloading that from the destination to the source, I'm downloading that, or from the source to the destination we are transferring that. So that is required the identity. Yeah, so how it is going to work with that identity over the network to transfer the data between one system to another system. Yeah, if you're accessing the Gmail application and you are sending the mail is nothing but yes, from the Gmail server, yeah, from about our system through the browser, it is sending that mail to the Gmail server, and Gmail server, it is going to use the to address and it is going to redirect to that account. Yeah, so the main points what we have is source and destination identifications are the very, very important. We would like to transmit the data. But how the data will be transmitted over the network and what is the protocol that will be used? Here we are talking about it courier system or we are talking about it post office mechanism to transmit the data between the source to the destination. But over the network, What is the protocol that supports? Instructions. We need to follow that instruction, right? That courier guidelines, we need to follow it. Our post office guidelines, we need to follow that whenever we are sending that the data. Like
in the form of packets, UDP or TCP.
yes. Yes, in the format of the packets, it is going to use the protocol which are defined with the standard instructions. Using that instructions, it is going to send the data over the protocol. Over the network. So what is the protocol? TCP or UDP protocols. And we have the networks classifications. Yes, we should understand it. Yes, if you are going to design for about our three-tier application about all this stuff, yes, we should know all these classical networks and subnet masks. Suppose if you go to the like a taluka level or mandal level, then within the taluka we have the different different villages, and each village is having that some number of houses. It has been classified. The areas of that entire mandal, right? The same thing here also subnets in the network. Yes, if you are going to place that one system in one network, yes, in which network do you want to place it? That's we say that subnet. Yeah, we should know that the networks and subnets and broadcasting channels. Yeah, it is kind of the postman mechanism or courier's mechanism. So broadcasting, delivering that. And finally, the one more important concept which we should know, CIDR. That is a classless internal domain routing options. Yeah, so there are the concepts which we should know. And yes, the private addresses, public IP addresses. These are all the concepts which we should know it. But what is the main protocol that is going to use it is? That is a TCP, or we have the UDP protocol also. TCP or UDP, we say that. That is on the basis of the wireless mechanism, the wire-based, and the reliability of the data. That means we should not lose that any packets. Or some of that application, even some packets, if you lose it also, no issues. Yes, that's fine. Suppose video streaming or gaming application. So even some packets have been received while video streaming, then we see there's some blur or some kind of the disturbance, but it doesn't give that impact to the transaction. But if I'm going to transfer that transaction data, then I should not lose that even single packet. So that is the reliability. The reliability and transmissions based, we have the TCP or UDP protocols which are supporting. Now, what is the TCP is? This is used for the network communications. Yeah, the TCP, that is a transmission control protocol. And what is that IP is? That is internet protocol. Yeah, the transmission with internet protocol based. Yeah, TCP controls the data exchange between the source to the destinations. And IP is going to send the data from one device to another. As we're talking that source identity is required, and destination. Who is sending, that is source, and who is receiving, that is destination. But both should have that their addresses or not. Yeah, that is IP address, we'll call it, which is sends data from one device to another device. And hosts, yes, normally like we say that servers are hosts or virtual machines. But in IP terminology, that is one of the device. We'll call it as a device. Device that could be about our laptop, or that could be about our server, that could be about our mobile. Yes, if the mobile is having the internet is not internet it contains is nothing but that is having its specific identity. That is IP address. Even printer. is also one of the device which is going to have its own identity. Over the network, you are accessing that the printer is nothing but it is having its identity. From about your system, you are connecting to the printer. Yes, your system is a source and the printer is a destination. Your system is having about its own identity and about your printer is having its own identity. These are all devices over the network which are transmitting the data. Yeah, the host, but don't think that the host is nothing but only about our virtual machines. Even that could be router, that could be switch, that could be, yes, about our virtual machine or printer or any device which is required some identification over the network. Yeah, devices on a network that have an IP address. Yeah, all these keywords and the terminologies are the important. Yeah, IP networking, how it is going to work with that? Yeah, with IP address. Yesterday, whenever we are after launching that Apache service, but from the Windows, if I would like to access it, that Apache service, first we are going to identify that IP address of the system. Otherwise, you cannot access that. Even the HTTP service is up and running it also. If I don't know that IP address of that system, then I cannot access it. The IP address of that device is important, which is having the 4-octet notation. So octet 1, octet 2, octet 3, octet 4, 4 octets. This is IPv4 format, we will call it. But whenever we are using this IP address is one device. That could be virtual machine, or that could be printer, that could be router, or that could be switch. That is one of the device. But the device is belong to that in one of the subnet. That is area. In which area this device is located. Suppose I have those 15 systems, one group, and another 15 systems into another group. Yeah, we have those like suppose if you just observe that postal the codes like postal, I mean, I have the pin codes, right? Each area is recognized with its pin code, but within the pin code, each address, I mean, each home, it is identified with its house number. So group of all the house, they are given that one unique pin number. That pin number, what we can say the subnet, that contains group of devices. And each device is having its IP address, but that IP address is belong to that one of the subnet mask. Subnet is a group of devices that contains. Like how we have the postal pin code, that is area wise. And in that area, each house again, it will be recognized with its own the IP address. I mean, that is, which you can say the house number. Yeah, subnet is group of devices which are belong to that. And broadcast address. Yeah, this is the sharing the data, distributing the data. Yeah, once if you know that IP address, that IP address is having its subnet mask and as well as broadcast address. And with its device identity. So if you just observe this 4-octet IP address, it is having that information about this IP address is belong to that which group of devices. That means which subnet mask or which area. And what is the broadcast channel that can be used to distribute the data. And what is the device ID. That means to which device. Suppose in that the subnet, I have the 15 virtual machines. That means 15 systems I may have that. But to which system it has to be sent the data. So system identity, that system is belong to the which group, and what is the broadcasting channel that can be used to share the data. All that information that contains in one IP address. Yeah, which contain the 4-octet notation. And each octet values can be from 0 to 255. That starts from the 0 and end to this 255. That means overall 256. So here 256, here 256, here 256, here 256. That means the total how many the permutation and combination of that IP addresses that we can have it is 256 into 256 into 256 into 256. That's approximately 3.6 or 7 billion the IP addresses that we can have it from this IPv4 format of address. This is we say that IPv4 format of the address. Is it clear? Are you following the points? If you just keep this, yeah, if you just keep this the point in mind, like as about our courier system or postman, I mean the post office, how it is working over the network. If I'm so if you're submitting, I mean if you open the browser and if you submit some data is nothing but yeah from about our system, that source system, it is going to send to the some destination system. But over the what is the network or what is the internet? First of all, internet is group of networks. What is a network? There is a group of devices. But what is a device? That is having one unique identity, unique IP address. That could be printer or switcher, or that is about our virtual machine, which can receive the data or send the data from that device. Yeah, so that's the main point, understanding what is IP. So always we use the keyword IP address, IP address, IP address. IP address is nothing but you are giving that device related identity. As a human beings, we have this about our name is identity. Like that about our devices, how it is going to have that identity. Suppose if I send the, if I'm accessing the internet and if I submit some request in the browser is nothing but response, it has to get it to my system only, right? Suppose if I log into the Gmail application and once I enter that user email ID and password, and if I submit the request, that home page, if the valid, if the home page has to be displayed in my device only, but it should not go on to display this in other device. But how it is knowing that my device ID? How it is able to send the server to only my device? The Gmail server. So whenever we are submitting the request from about our system, that is IP address is sending that in that request. And the server once it is received and it is processed the Gmail, and whenever it is given the response back, it is going to take that IP address, and to the same IP address it is returning back that response. Yeah, so IPs are going to play important role on the networks. Not only the IP, but the IP is belong to that network. And networks of the networks, that is internet. Yeah, IP networking. So which is have the network address. Yes, one IP address if you just identify that. So that IP address which is have the network address and as well as host address. Host is nothing but device address. It is like as a about our the house number. But the house is belong to that in which area? Area is about our network address. Yeah, network address and host address. There are the two important things. Each must be unique for proper routing. Yes. First of all, area is required, right? That is a pin code based identifying that. Then after that, okay, street address, we have some other options. And but unique house is which house that do you want to send it? Host address. Each must be unique. Suppose if you're talking about it, Hyderabad is available in the two places, but you need to have some unique identity of that, right? Yeah, this Hyderabad is belong to that India's one or Pakistan's one. Which one is that? Which one Hyderabad? Do you want to send the mail? You need to have that. That is unique identity of the proper routing. So all that will be decided on the basis of the address classes. Yes, IP address is having the address classes. So these are all going to helpful to determine the network address and host address. Yes, now whenever we see that IP address, we should able to understand as a DevOps engineer, because networks also very, very important for us. Don't think that networks, that is network administrator. Okay, designing point of view, the network administrator comes into the picture. But whenever we are working that's on the infrastructure side, you are launching that one virtual machine is nothing but first of all, you need to decide that in which network I would like to launch it that. Network you are going to deciding is nothing but that is the area. In which area that you want to place it about your virtual machine. And what is that identity that you want to give it to that virtual machine? That is a host address. Host address and network address. Understanding from that IP address is very, very important. But how does this the classification that they have come up that? See, all these mailing addresses, the the post office pin codes and all that, someone has designed it, right? The government level, it is designed identification point of view. Like that in our networking also, how the networks are working this is, yes, we have some classification from the IT the team. So we have the standard structure. So they have defined different classes. So what are the different classes? If you just observe that class A, class B, class C, we will call it that. And class D is also available, but there is a broadcasting normally which we don't use it. There is a multicasting purpose which we use it. Yeah, most of the classical networks A, B, C. But what is that the class A? What is the range of IP address that we have to say is 1.0 to that 127.0. That means as we're talking that 0 to 255, right? Each octet. Yeah, first octet which starts 1 and it's end with 127. Between all these the IP addresses which consider that as a class A. That means how many hosts we can get it. So these many IP addresses that we can have it in this network. From the class A, almost we can say that 1 crore 67 lakhs 77,216 number of devices that we can have it in the class A. But do we see that those many number of devices placing in the single network? That is a huge or large network, right? Normally we don't get that the chance using that these many devices in single network. But if you need it, yes, you need to go for the class A type. This is for huge network or the large, the large number of devices you are planning to launch it. Up to how many? 1 crore 67 lakhs devices you can place it in this network. And class B, how many IP addresses that is supporting this is? Yes, if I use it the class B, my requirement is number of hosts up to 65,536. Then I can go for the class B range of IP address, which is supporting that next after the 127, 128, 128 to 191.255. If you see this starting from the 128 to 191, we say that this is the class B range of IP addresses. And if you use it, this is a network, this subnet mask, how many IP addresses we can get it? 65,536 IP addresses. So these are all like, okay, there's some medium type, the networks. If you're expecting in one network, approximately 60,000 devices you would like to place it, then you can plan it B. But normally we don't see that many, not required. But most which you use it is, that is a C type of the class which is supporting that 192. After the 191, 192 which starts the 002 233 up to that 233.255.255. This is about 255 devices that we can have it. That means my requirement is I'm planning to launch it virtual machine, 20 virtual machines. 20 virtual machines for planning is nothing but then you can use it class C range. You can use it up to 255, but some of the IP address still you are losing this, right? You need it only 20, but you are going to use the class C. That means it is going to give the 255. That means unnecessarily you are going to waste that remaining 235 IP addresses. You are not utilizing that. But my requirement is 20. Yes, obviously we need to go for this one. Yeah, this is, I mean, before the latest model, if you just try to understand that, how they were using that, the class based networks is class A, class B, class C are available. Huge networks like, the 1 crore, some kind of the devices, if they are planning that, number of IP addresses. Devices, if I talk it, number of IP, even mobile, yes, one device, printer is another device, router is another device, switch, one device, virtual machines, yes, each virtual machine has a device which uses its IP address. So if you have those requirement on the basis of these ranges, you can decide about that class A or class B or class C. But suppose I need that 1000 devices in one network. Then what is the class I need to use it? Which class
Class
I
B. Class
yeah.
B.
Yeah, which class we need to go for that is obviously class B. But I need that only 1000, but class B, if I use it, I'm going to get it 65,536. That means the remaining all the IP addresses are the waste, right? You are not optimizing about your device IP addresses. If you go for using this class based, this is the class based networks. If you're going to use it, you cannot split as per about your requirement. As it is there, you need to use it that. But with the subnet mask is the which we can have it. Subnet is going to helping that it is kind of area as we're talking about. Area. Subnet is area where all the devices can be placed. Yeah, in the subnet, I need to place it 1000 devices. Then class B, I need to go for that. But on the base of these classes, subnets, how do we have those? You see that here, class A subnet is 255. Is the first octet 255 and remaining 3 octets for the device. So first octet is network identity. Remaining 3 octets for device identity. So that's why we can have it how many devices? 256 into 256 into 256. So approximately 1 crore 77 lakhs of that devices that we can have it with the permutations and combinations. But first octet is for network identity. Remaining 3 octets for device identity. Suppose class B, if you go to that, how many IP addresses we can have it? 65,536 devices. 65,536 devices is nothing but first 2 octets of our network. This is a subnet identity. That means area identity, area, subnet. And the last 2 octets for that, once it is entered into that area, house number is last 2 octets. This is a class B. That's why we say that 256 into 256, so 65,536 devices that we can have it in the class B, which is having the subnet mask. First 2 octets for the network, last two octets for the device. Suppose if I see something 192.168 dot something 0.1, what is the meaning of that? 192.168 is a subnet identity, network identity, and 0.1 is my device identity. 0.1, 0.2, 0.3. So these are all my device identities, device IP addresses. But first two octets were network identity. And class C, if you go further, as we're talking the 256 IP address, 256 is nothing but last octet, right? Last octet is the device identity, and the remaining three octets were network identity. That is area of the network. Yes, this device in which network is available. Suppose here you have something 10. Okay, this 10 is belong to that which network. So first it connects to this network. That means area. In that network, it is going to route to that the device which is having the 10 identity. Yeah, class A, class B, class C. So they're all the subnet classes which are available in the market. But these are all not having that optimizing the IP addresses. These are all class-based dependency. Now, if we talk it this one 255.255.0.0, which type of the class is this?
B.
Yeah, if I see the subnet like that 255.255.0.0, we can understand that first to these two octets, like here 193.194, this is the network identity, and 46.31, these two are for my device identity. Suppose here the 255, 255, 255, 0 is there. Then what is the meaning of that one? That's under class C. Yeah, class C. And 183, 194, 46, these three for network identity. And the last one is for within the network device identity. Yeah, if you know that the subnet, if you know IP address and IP address with the subnet, then we can understand it. Okay, which are all the octets for the network and which are all the octets for device. Yeah, this understanding is very, very important. Because whenever we are working in the cloud, working with the VPCs, working with the subnets, and you need to define the CIDRs for the subnets, CIDRs for the VPCs. And whenever you are allocating that the virtual machines and launching the virtual machine, you need to allocate in the particular subnet. Yes, in which subnet? How do you identify the subnet identity and system identity or device identity? So these are all the very, very important concepts in the network. And later we have some commands. Yesterday also we are understanding ifconfig is one command to know that list of all the IP addresses. Yeah, this is the class based. But class based, what is the limitation that we have is, or what is the disadvantage we have is, we are not able to optimize that IP addresses. Yeah, if I need that 256 under, okay, good. Class C, I can go for that. But if I need something 2000 devices in one subnet, I need to go for the B. But B, if I use it, I can get it to 65,536, but I'm going to use it only 2000. That means remaining all the IP addresses are not optimized. So for that, the latest approach, what do we have to say? CADR concept. That is a classless. We are not going to depending on the class. Classless inter-domain routing. So this is the important, as in the cloud, whenever we are going to talk with that. Yeah, the classless inter-domain routing. But this also have the subnet concept and identity of the device concept. All are same. But if you need that only 1000, yes, 1000 devices related subnet mask, you can define it. Subnet mask, that means subnet and the device identity. Only for 1000 if you need it, yes. Nearest to the 1000 you can identify it and you can define that. That is the beauty of this. But what is the notation it is having is, so this is having that IP address, that is a 4 octets, and after that the slash and the number. Yes, this number is helping to decide that this IP address, how many octets for the network and how many octets for the device. In the normal class A, class B, class C, suppose 121. 121 is belong to that which class? Which class is that? 121? Class A, class B? Normally, if you
Class
just
A.
talk it,
Class
yeah,
A.
class A. Normally, class wise, if you just talk it, this belong to the class A. But in the classless, you don't need to worry about that which classes belong to that. Forget about that. But here, by observing this /8, yes, we can understand that whatever the class doesn't matter, that the which subnet it contains. If it is a class A, we have the first octet for the network and the remaining 3 octets for device. That's why we say that 256 into 256 into 256, that is a large or the huge networks that we can have it. But even that class A also we can split into the small units. But what is the /8 notation will come back. Yeah, so whenever we observe this one, this comes under the class A network, which is belong to that 121.0.0.0. Yeah, what is the /8 here? It is represented. That is subnet. What it is going to have it is. Yeah, so that is 121 is for network identity and 000 is for the device identities. And what is the subnet for this one? Yeah, 121 is going to become the first octet is a 255 and remaining octets are device. And what is the broadcast address of this one is? So 121 is the first octet as it is, but the remaining 000 whatever we have, that's going to become that 255, 255, 255. This is the broadcasting address of this IP address. So once if you know that IP address with the CADR notation, okay, CADR leave it that for the timing here, /8 leave it off that. But what is the meaning of this one is, if I see this 121.67, 121 is belong to that class A, okay, class A network. That means 121 is the network and the remaining 3 octets are 0. If you know that information, then we can have the subnet mask. Subnet mask, what is that? The first octet is network, right? Network octet is going to become the 255 and the remaining device octets is going to become the 000. Device octets are the 0, network octet is 255. And if you convert this one into the broadcasting channel, network identity is as it is, that is 121, but device octets, whatever we have, that's going to become this as 255, 255, 255. Yeah, if I see this broadcast address, what I can understand is, okay, 121 is a network address and the remaining 3 are for device. Or if I see the subnet which is showing the 255.0.0.0.0, what is the meaning of that? Or how we can understand this one is, okay, first octet is for the network and the remaining 3 octets which are having the 0 are for device. Yeah, if we know IP address, then we can get it that how many IP addresses that we have in that network. What is the network ID and what is the device ID, we can easily get it. Now, if you observe this IP address, network ID is 121 and device is 67.198.94 is the device ID. To that device in this network, it will be routed the request. Yeah, another CADR notation, suppose /64. So what is the slash 64? How that's we will use it is, let me explain some small concept about this area. Then I'll come back to this explaining these examples. Suppose, let me take it this IP address. What is this IP address which you're talking that? Yeah, so this is one IP address. Okay, this is a classless interdomain. So we say that this is the CADR notation. So if you just split this into the two sections, the first one is, this is IP address. And the second section, what do you call this one is CADR notation. So CADR value is 24 and IP address is 121.67.198.94. Okay, you have seen that IP address like this with the slash 24. Then how many and what is the subnet of this? What is the broadcast channel of this? Or what is the which class? Okay, that's fine. Class is fine. And how many number of devices that we can have it, and what is the device ID of this? How do you know that? Yeah, in the classless interdomain. So what are the value we have this? So that's value first subtract it from the 32. So what is the CADR value we have is 24. That's 24 subtracted from the 32. Always subtract from the 32. So 32 minus 24, 8. So now that the remaining value, whatever we got it, that's 8. That is 2 power of 8. What is the 2 power of 8? That is 256. So we can get it the 256 IP addresses from this device. That is the meaning of that. 256 IP address is nothing but last octet is for the device and the remaining 3 octets for the network. 256. This octet is given the 256, right? That means remaining 3 are for network and last octet for device. Then what is the subnet from this? Can you give me the subnet? What is the subnet of that IP address? 255.255.255.0. Device octet whatever we have, that is 0, and the network octets are 255 in the subnet. Are you getting the point of it? So total how many devices we can have it? 256 number of devices that we can have it. And what is the subnet? 255.255.255.0. And what is the broadcast channel? That is which transmit the data. The broadcast address. So network ID same as it is, you'll be having that. The 3 octets are the same, but device octet is going to become that as a 255. This is a broadcasting address. So once if you know the CADR, with that CADR, we can understand that how many devices that we can have it and what is the network ID. What is the network ID here? Network ID is first 3 octets. And what is the device ID?
94.
Yes, that is 94. Last octet is a device ID. So first it is going to this network. In this network, it is going to route to this 94 device. That means that system is going to receive the request. Is a clear understanding about this classless interdomain? Class-based, yes, we have straightforward. 0 to 127, okay, class A. Which will be having the is first octet is for network and remaining 3 octets for the device. And next to 127 to that 192, 191. These all belong to the class B. How many devices? Last 2 octets for the device and first 2 octets for the network. Totally you will get it 256 into 256. That is 65,536 devices. And the class C is that is 192 that something 233 up to that which is available. But CADR notation is the latest trend in the cloud. Whenever we are working the cloud networks, yes, we see this is the notation. Suppose, let me talk at one more point. One more example. Suppose if I say this one and with something 16, then what is the meaning of this one? What is the network ID of this?
121.67.198.
No.
That ID is first 3 octets, right?
No. Here, what is the CADR I have mentioned?
Okay. 32 minus CIDR.
Yeah.
So we get 16. So 2 power 16.
Yeah. 32 minus CADR, that is 16. That's
16.
equal to 16.
2 power 16 equals
2 power 16 equal to, that is 65,536. So 65,536 nothing but 256 into 256 as simplest. That means last 2 octets are for device and first 2 octets for network. This is the network ID. And what about the device ID?
last 2 octets.
Last 2 octets, that is 198.194. This is about device ID. This is like as a house number. And what is the subnet? What is the subnet for this one? Network ID is going to become the 255. And device ID is going to become the 0. This is a subnet mask. And what is the broadcast address? Network ID as it is going to have it. First it has to route to that network, right? Yes, network ID as it is. But device ID, yeah.
255.
Device ID is going to become that 255. Is it clear about this?
So after getting 32 minus CIDR value, after getting that again we have to classify according to class.
Yes, correct.
Okay, got it.
Yeah, now let me talk at one more example. Suppose if I use it 0.0.0.0/0. So what is the meaning of this one?
It is not visible, sir.
Not visible.
Now okay.
Okay. Yeah, what is the meaning of this one?
32 minus 0, 2 power 32.
Hmm.
So 2 power 32 means
It's not even class A.
class A. Class A.
Class A. Okay, classes wise leave it off. That is one model, but that is a old model. Now nobody is using that, but understanding that is required.
Okay.
But now latest model is classless.
For means for network ID, device ID, we have to find out which octet is for. That's why we have to go to that only.
Yeah, correct. But here I have mentioned 0000/0.
Yes.
What do you understand this?
Network ID is 0 dot, that's it, 0. Device
Okay.
ID is 255.255.255.
Do you have the 255 in the device ID? No.
Okay, 0.
That represents.
It's not invalid IP address.
We should not say that is not invalid. That is valid. So this is meaning of that. Any network, any IP address.
Okay.
So here there is no specific network ID, there is no specific device ID. So any IP address will say that. Yeah, any system to any system, it can communicate it. So whenever we are defining the, suppose we need to allow that public. Suppose whenever we are defining the firewalls, we need to allow that all IP addresses. But all IP addresses, how do I define it? From any network or any IP address which are receiving, we should allow that request. The public, we don't know that specific IP addresses, right? But within about our internal networks, okay, we know that, okay, this is a network ID, this is the subnet ID. But from the external public, suppose what is my public IP address? If I check it, that is going to have some XYZ. And what about your public IP address? Some XYZ. But Gmail team, they need to allow that my IP address and about your IP address. Because they don't know that what is the public IP address which we have that whenever we are connecting to the internet. So they should allow that from any network, any IP address. Then what is the CADR we use? It is 0000/0. That means 2 power 32. The 256 into 256 into 256 into 256. Those means, that means all IP address it should be allowed.
Like all whole 32 bits for the IP, right?
Yeah. Yes, correct.
Okay.
Here there is no network specification. Any device it can access it. Suppose next if I define that something 192.168 dot something 20.21/32. What is the meaning of this one?
It's not under in classless settings, so class-based.
So here what is the formula you're talking that? 32 minus
32.
area
0.
0.
2 power
2
0
power
is
0 is
0 is 1.
1.
That's equal to 1.
1.
That means
192.
only this IP address is the representation. Only this IP address. There is no other IP address. How many IP address we have? How many devices? Only one device.
Correct.
So this is the only one IP. That means actually if you consider about it, okay, this is a network and in this network only this IP address will be allowed. There are no other devices. That is a representation of /32. That means I'm expecting only one IP. Suppose I need to allow that the firewall only from my system. How I can define it? My system IP address I'll define it and /32. That means only from this IP address that will be allowed. Are you getting the points on this?
Yeah, perfect, sir.
Yeah, good. But instead of struggling all these things, manually calculation and all that. So we have this one site, the where we can use it, that site to know that all these the notations. Okay, suppose what is the address is IP address. The info some site is available. I try to find it. Yeah, if you'd like to get about your public IP address, you can use it. What is my IP address? Suppose if you'd like to know about your system public IP address, so what is my IP address? If you just let me in the Google, what is my IP? We just type it. Yes, this is my public IP address. Yeah, whenever you would like to know about your public IP address about your system, yes, this is you just type that in the Google. What is my IP? Then you will get it about your system public IP address. But public IP address must be unique. That means this IP address in the world, nowhere it is going to assign this IP address to other devices. Only about my device, that means this current laptop contains this IP address. Suppose from the system, if I do that, like any kind of the activities, so that's everything that will be tracked. As if you're doing the Gmail, yes, Gmail activities that will be tracked. So how the cybercrime teams, they are going to tracking that the activities which are happened in our mobile. So in the particular time, where are you? So recently Google out something that has come out, right? How it is tracking that? Yes, you are connected from about our mobile. Internet is nothing but that is going to assign one public IP address. That IP address is dedicated to about your system. So nowhere in the no world that IP address is not going to assign to that other devices. And until that network is available, that IP address is available, and whatever you are doing this in the mobile, everything that will be tracked. Yeah, so this is the IP address of this system. So if you like to know that, what is my IP? If you just type it, you can get it, that IP address of the system. But what is that another URL or link which we have? This is, let me try to get that. That is IP address guide, something which is available. Yeah, so this is a site ipaddressguide.com. So free IP addresses tools for the IPv4 and IPv6. Suppose whenever we see that CADR notations, and if you'd like to know that how many IP addresses are available and what is the subnet mask for it, all those details, you just IP address guide. Okay, so here you can find that CADR some subsection. CADR, if you go to that. Yeah, so here you can see that's a CADR. Suppose as we are talking about it, 192.168.20.21/32, if I give that, then I will get at all the details of this. Yeah, CADR range. Yes, this is my CADR range. And what is the subnet mask? This is the subnet mask. And what is my first IP address? Yes, this is my IP address. And even the last IP address is also same, right? First and the last, both are the same. That means how many hosts we can have it in this CADR? Only one. So this is CADR notation. Suppose if I give the something 24. So what is the subnet mask for this? This is a subnet mask. And what is the first IP address from this is 192.168.20.0 is the first IP address, and this is the last IP address. That means you see this first 3 octets for the network and the last octet is for the device. And total how many hosts that we can have it? 256 devices, which starts from the 0 to the 255. Those many devices we can have it if I use it this ADR notation. Or I need to have something like 50 devices in subnet. The 50. So if go for increasing this one, suppose if I go for the 25 CADR, then you see this, it is decreasing the devices. Okay, still 128 it is given, but I need that 50 only, 50. Then what is the CADR? I can use it. Then let's increase this next one, 26. Okay, it is nearest to the 50, 64. Yes, if I use it this CADR, suppose if I use the 27 CADR, then how many devices it is given that? 32. 32 is less, so that's what I'm expecting, the 50. So if I use the 26, then I will get it that's nearest to my devices, right? Now I can take it this area and I can use it in the networks. Then I will get it up to 64 devices. Okay, 50 I'm going to use it. Maybe future case it is going to helping that. And especially in the cloud, you are going to use it. Cloud is going to use it internal from the subnet, some more devices. You need to have some additional 5 devices. So suppose you are planning 50 is nothing bad. Your requirement is 50, but 50 plus 5. 5, why do we need it to have it? Cloud internally is going to use the 5 additional devices from that subnet for broadcasting or internal feature purpose or whatever that. So 55 you need to plan it. Then you can choose it this area that supports that. Yeah, so this site is going to helping that instead of manually calculation, but manual understanding is important. How it is happening there. So yes, now you see that 32 minus 26. What is that? 6. 2 power 6. What is that value? 64. So background, what it is doing is that formula, whatever we discussed. But instead of struggling that instead of breaking its heads, we can use it at this ipaddressguide.com/CADR that helps about it to define subnets on the base of the devices which are required, number of devices. But why do we need that number of devices and all these subnets? That is, I'll come back later. That is in the application architecture point of view. That is web servers, app servers, middleware servers, database servers, reporting servers, monitoring servers. We launch it in the different networks. We don't launch it everything in the same network. So how many databases required? How many databases? Those many number of devices required. Or how many middleware servers required? How many the web servers that is required? HTTP services. As per that number of services which are required for that application, and each service has separated to manage its separate networks, and within the network separate devices we define it. That is in the architecture level. I will conclude it one day of that higher availability architecture. But networking concept, this is very, very important. Understanding the CADR notations. Or suppose if you need that IP range. Yes, if you have that IP range and you would like to know the CADR. So then suppose 10.0.0.0 is the first IP address and this is the last IP address. Then how many devices will get it and what is the CADR notation for it? And if you just calculate that, then yeah, so this is the CADR for it, 10.0.0.0/24. Suppose I need that only 64 or 50. That means we are looking at only the 50 devices. So you need to use it. There are the different CADRs. Yeah, we know that this CADR is going to give that one IP address. And this is going to give the 2 IP addresses. 1 plus 2, total 3. And here this is going to give that 2 power 4. 2 power 4 is nothing but 16. And this is 2 power 5, 32. 32 plus 16, 48. 48 plus 250 and 1. Yeah, so here it starts at 0, right? Total 51 IP addresses. Getting the points of this? Instead of using these many, just go for that. Yeah, nearest to that. That is, with one CADR, we can manage that. Are you clear about these points? The networking CADR notations, class-based and classless based.
Perfect, sir. We understood.
Yeah, quickly, if you just observe that a /32 meaning is nothing but only one IP address. So /31 is nothing but 2 power 1, that is 32 minus 31, 1, 2 power 1, that is 2. So like this, yes, this is a notation. Understanding the formula behind that. And some most commonly used CADR notations. Please mute the mic.
తగ్గిందా మీకు
Yeah, /32 means the no IP number can be changed. /24 means last IP number is going to change it. That means last octet. /16 is nothing but last 2 octets, the device, and first 2 octets for the number. And the /8 is nothing but last 3 octets for the device and first octet for the network. And the /0 is nothing but all IP numbers can be changed. Yeah, these are all the most commonly which we should remember that. Understanding the CADR IPv4 classless internet domain routing, yeah, they help to define an IP address range and one IP or all IPs. Or, but we can define, for example, 192.168.0.0/16 also, like this. That is 64 IP addresses. Yeah, as we're understanding, CADR is have the two components. One is IP address and second one is subnet mask. That's a slash number, whatever we are viewing that is we say that subnet mask. Yeah, the base IP represents an IP contained in the range, and the subnet mask defines the how many bits can change in the IP address. Yeah, as we are talking this in the first format, class-based format, 255.255.255.0. So this is one notation, which we use it in the current market, less common. But the latest trend is CDR notation. This is the more common. Suppose if I log into the system and if I go for that IP address verification, let me go back to the background machine which we are using.
So we are unable to see your screen.
Yeah, yes. Yeah, now do you see that?
Yes, sir. No. Yeah.
Yeah, suppose if I type that ifconfig, how do we see this list of all the IP addresses on the system? Ifconfig, if I use it. Yeah, so these are all like, I mean, total how many interfaces are available is Ethernet 0 is one interface, Ethernet 1, ETH that stands for Ethernet. So we use it Ethernet based communication channels, but we have this 0 and 1, 2 interfaces, and this is the loopback. Yesterday we were talking about the local host, right? Local host. The local host is that by default loopback adapter. Any system which you are launching, that by default it is going to have the loopback adapter. That is a local host. Yeah, local host, what is that IP address is? This is the IP address. 127.0.0.1 is the IP address. And what is the subnet mask if you see? 255.0.0.0. That means first octet is for the network and the remaining 3 octets for the device. But always it is going to have that one, always the same. That is local host representation. This is the local loopback. You cannot use it for external. And whenever we are talking about that interface is going to helpful to receive the data and to transmit the data, that is sending the data. Yeah, in each interface, through this interface, we can see that how many packets, so that is R for receive and T for transmitted. So sometimes networks are going to get failure. The interface, if it is failed, yes, something network is dropped. Suppose Wi-Fi power cut and Wi-Fi is disconnected. That means that network interface is dropped. Then all the packets we will lose it. That is receiving packets or sending the packets. That's we will lose it that. But you are receiving the packets or sending the packets is nothing but that is happening through one of the interface on the system. But we can analyze at each interface point of view how many packets that have been received and what is the byte size of it. This is 197 kilobytes of the data that has been received through these many packets. 28 packets have been received with this amount of the data. But do you have any errors? Or do you have any dropped packets? Yeah, we should not see that dropped or errors. If you see the dropped, that means some packets which have lost it in the transaction. Like that Rx, that is for the received, and Tx, that is a transmitted, sent it. How many packets it has been sent it, and what is the amount of the data that has been transmitted. But this is the local one. But main thing, yesterday we have configured the Ethernet one. And this is the IP address of this one. And for this IP address, this is the subnet mask. That means with this, what we can identify this is the network ID and this is the device ID. That means if I'm going to launch it one more system into the same network, how do I can launch it? I can use the network keys. This is the network ID. And I can give that next IP address is 11. So 10 is this system IP address. And if I'm going to launch it another virtual machine with 11, that means 10 and 11, these are all the two different IP addresses, but are in the same network. Then they can communicate internally each other. If the two systems are in the same network, then you don't need to have the public IP address. You can have it with the private IP address itself, internal communications, if all are in the same network. Yeah. So if you know that IP address, and we can get it that net mask, and this is a broadcast address, you see that this is a broadcast address. So network ID is the same as it is, but device ID is going to have the 255. What is the subnet mask? Subnet mask is the network ID is going to have that as 255, 255, 255, and device ID is going to become the 0. And this is the inet6, that is IPv6 format. IPv6 format, there is no standard format. That is some hexadecimal notation it is going to use it that. And how many packets that have been received, and how much bytes amount of the data that has been received, or how many packets sent it, bytes amount of the data. Do you have any errors or the dropped packets? Especially errors, we should not see that. So like that, each interface, that interface related IP address and what is the subnet mask, and using the subnet mask, we can identify that ID of this and broadcast channel and the amount of the data that has been received or transmitted. So this understanding is required on the IP based. Is it clear about that? CDR notations and with IP addresses and how do we analyze it and how do we check it about that? Do we have any errors or packets dropped over the through the network channel? So this is the network channel which is using between my Windows system to Linux virtual machine. Actually here I'm getting internet or not? Yes, this system is also having the internet.
Yes, yes.
But I didn't use it any Wi-Fi directly in the virtual machine. My Windows system is having the Wi-Fi connectivity. But what of the internet which I have this on my Windows system, that is shared to this my virtual machine. How it is shared? Through this network interface. So it is going to use it internally NAT mechanism or bridge mechanisms. Yeah, through the NAT. So it is going to have that all the Windows to Linux based communications. Suppose how do I check it whether I am able to connect to the Google? I mean, whether I may have the internet or not on this system. How do I check it? Yeah, we have another command. That's a ping command. Ping. You can ping it. Ping is what it is going to do. It is going to send some test packets. Yes, some test packets it is going to sending to the URL which you are going to specify that. That is URL is google.com. Normally in the browser, how do you test it? Your net is working or not? Simply we'll search it in the, when we type that in the browser google.com, right? The same way here, ping google.com. Ping is the command which helps to test it whether the particular site is reachable or not. If the site is reachable, is nothing but network is reachable. So now I am trying to ping it, but it is not pinging. So I don't see there's any response. That means the maybe like network has been dropped. Yeah. So name or service not known. Google.com it is not able to ping it that. So if I have restarted the system and maybe it works for that. So is it clear about that IP address understanding? The CDR notations and class, but class based nowadays nobody is using that. But I understand that concept as well as that is a old architecture. But the latest cloud and more optimization of the devices point of view, the CDR notation. So as a number of devices point of view, you can define that the subnet mask. That is with the CDR notation. Yeah, so that's all for today from my side. But still, we have some more concepts understanding, some more commands from this networking. Are you available tomorrow?
Yes, sir.
Shall we take it this tomorrow, the class online? Everyone quickly confirm this in the chat window. Then same time around 9:40 we will join it and we'll continue. Okay, I see there's a positive response. Ajay said okay, Sushma okay, Usha okay. Okay, Srinivas, he's having that weekend activity. Anyway, we'll be having the recorded class. We'll share it that. So if one or two members are missing, you can just I'll send this in the chat win. I mean in the WhatsApp. I'll confirm that. Just to spend the same time, the 1 hour something. If you spend it, then you can get back that. Okay, other than Srinivas, the remaining all members are confirmed. That means voting percentage is good, confirmation percentage. So we'll continue. So shortly 9:40 we will log in it. And we'll try to conclude about this networking, some more commands. Yeah, these all are important to the DevOps engineer. Don't think that they're all the Linux activities. Next, the cloud, if you are going to work with that. VPC designing, subnets designing, and understanding the public IP addresses, private IP addresses, network interfaces, all are very, very important. Yeah, that's why we need to have the DevOps in here, networking concepts, OS concepts, DNS concepts, database concepts, middleware concepts, web server concepts, and with the programming, that is scripting approaches, that is a shell scripting, Python.
Playbooks.
Sorry.
Yeah, we can write a program like a deployment act with the Ansible playbooks. Like
Yes. If you are going to work with that Ansible playbook, then you are going to use it all these concepts over there, especially if you are working for the OS operating system. Like how to install the packages, how do I manage the services. So on this top of the Linux, we are going to talk at one more layer whenever we are going to discuss the DevOps. So there we don't use it, yum install command, but that concept we will use it whenever we are writing that with infrastructure as a code. So yum install or yum demo or whatever we are talking that, all these commands, we don't write it directly these commands, and we write it one code to install the package or to manage the services. But to understand all those concepts and all these things are mandatory. Yeah, so this network management, now we are talking that, and that's required one more class for me, network side. And next another concept, users management. Yes, that is required one class for me. And after that, I need that one class, that is high availability architecture. Yeah, so maybe tomorrow if you take it, 2 more classes that is required in the next week to conclude the Linux activities. Then we start about that. Linux is not ended. Then we start the shell scripting. That means whatever we have learned, all these activities, how to write as a code. That is the shell scripting approaches. Then we talked about the cloud. That is AWS. And after that, the DevOps tools. That is one by one, we'll come back. But do as much as which you can practice it and practice it. If you are the master on all these commands and with the options also we are talking that, remember it. PS we discuss some options, and find command we discuss some options, and grep command we discuss some options. Options are going to play very, very important role whenever we are writing the scripting. Okay, good. Anyway, we see this all those things, but the everyday activities try to complete it, and review. I mean, the weekends review it 1 or 2 times the activities which are performed on that week and previous weeks. So if you have that habit, that's like a revision of the labs and revision of these concepts, then whenever we are talking about it, cloud or AWS, then it will be easy. Okay, good. So that's all from my side for today. So I hope you enjoyed the class, and we'll see this tomorrow. It's sharply 9:40, and we'll log it.
okay,
Yes,
sir.
any queries, questions, please. So I see that like some people are facing this vagrant and not some, like one member. So who is that? So Raghava, are you here? Yeah, Raghava. Is it resolve the issue? Yeah, remaining people you can log off, no issues.